So you have that diagram there, and the question firstly is what's the area. So let me draw it again for you. Okay, so let me write in the measurements for you. The total is 15, but each of these are 5. So there, that's 5. That's 5. That's 5. And likewise here, that's 5. That's 5. And then that one there is 5. So if I want the area, I can break it up into 3 rectangles. So the area would equal 5 centimeters multiply 15 centimeters, yeah. And then you have to do that again at the bottom. And then this piece in the middle will just be 0.05 squared.
What?
It's 5 by 5. The little square in the middle. This one here.
But we don't know we know only when
No, but if you look, you're told that this is 15 and this is 5 and 5. So it must be 5.
Okay.
0.05 times 0.15 times 2 plus 0.05 squared. Alright, so it's small. I got 0.0175 meters squared. That's A, the area. If the length is 2.25 and the density is that, find the mass. Now, let me just give you some results that maybe you didn't know. Whenever you have something in 3 dimensions, look up, Andy. Whenever you have something in 3 dimensions, like a book or a calculator or whatever, if you know the area on one face, like here, and you know the length of it, then if you want the volume, you just multiply this area by its length. Okay? So here, the volume would be AL, which would be 0.0175 times the length, which is given as 2.25. So the volume (0.039 meters cubed). Now he doesn't want the volume, he wants the mass. So we can say density is mass over volume. So therefore mass is density by volume. So we have the density and we have the volume now. The density is given as 7,800. So when you multiply those two numbers, 307.125. So if you want 307 kilograms. Oh, good. He says to show that. Now the next one is, you take this and then you lift it up in the air. And you lift it 25 meters in 2 minutes. What is the power? Okay, so what's the formula for power? That's work over time. And what type of work is going on here? It's the potential one. So it'll be mgh over t, which will 307, 9.81, 25, and it's 2 minutes. It's 120 seconds. Okay. If this was to suddenly fall, all of its potential energy gets converted into heat. So we have to work out how much potential energy it has on the top. Well, that's just the MGH. So that's 75292 joules. Now all of this potential energy at the top, when it comes down and hits the ground, it gets turned into heat. So what formula then do we need for the heat one? How do we work out temperature? What formula? No. Oh guys, come on. It's the one we've been using for like the last 100 hours. MC delta T. Now what's the delta Q here? Well, that's 75292. The M, 307. The C, 400. So now we can work out how much warmer it is when it hits the ground. All of the potential energy got converted into heat energy. So it's about 0.6 degrees warmer. Okay. Now, stop. You got that? Not yet?